Okay, so I'm going to talk in this video about composite functions, which is from section 1.4. So the idea with a composite function is you glue two functions together. But before we talk about that, I need to talk briefly about what y equals x squared looks like. I know most of you know this, but in case there's a couple who don't. Okay, so y equals x squared just looks like this. So for example, the point 1, 1 is included, the origin is included, and the point minus 1, 1 is included, and if you want some more points, 2, 4 is included, minus 2, 4, etc. And it mirrors right here on this axis. Okay? So we need to know this, so you should add this to the list. I'll mention this in class again. I left it off the list. I'm sorry. But you need to know, you need to be able to plot a parabola. I did say you had to plot cubics and lines, but somehow that one got left off the list. Okay, so what I want to do is I want to plot the following function. It's going to be x squared plus 1 if x is less than 0, but it's going to be x minus 1 if x is greater than or equal to 0. So the point is, just to be clear, I'm going to plot both of these and then I'm going to cut them. And I will show you, I'm going to show you this in slow motion. Okay, so when you're really doing this, you don't have to take all these steps, but I want you to understand conceptually where it's coming from. So first of all, I'm going to plot x squared plus 1. So x squared plus 1 is you just take the plot of x squared, and like we talk about graph shifts in class, those points that we had before, they just all lift up. So this is what x squared plus 1 looks like. Then let's say we take the plot of x minus 1. It's going to actually look like this, right? And we talked about plotting lines also, so make sure you understand how to plot lines. So we have the plot, these two plots. What we're going to do is we're going to slice them. We're going to take, if x is less than 0, so we're going to take everything, I'm going to highlight everything over here. This is going to go into our final graph, and I'm going to say x equals, so x equals 0 is going to be included here, so not included over on this side because that side it says dotted line, right? The dotted line is to indicate that we're not going to use the axis point there. We're going to put the axis point over here. But then we're going to take for x greater than or equal to 1 this piece. So the parts that I've highlighted in red are the parts I'm going to take. Alright, and I'm going to see if I can shrink this so that we can, there we go. We can still see that. Then I'm going to try to put them together. Okay, so it's going to be x squared plus 1 over here, and that's from this graph, x squared plus 1 if x is less than 0. But then we have x minus 1 if x is greater than or equal to 0. And now I can ask questions about this new f of x. This is the whole f of x. Alright, and it's not continuous, right? It's got this jump discontinuity. If I had put a plus here, I would have fixed the discontinuity, but that's not what it says. It says minus. So it has a jump discontinuity. We're going to talk more about discontinuities. Okay, so if we were in class, I would ask you to do this. You try this. So what I'm going to do is I'm going to give you the question, and then I'm going to pause the video while I draw the answer so that you have time to, well, I'll have time. So the question is, and then in class tomorrow, we will go over this one. Make sure everybody got this. Okay, if x is less than or equal to -2, if x, so when I first saw these as a student, I didn't realize how easy this was because I was over analyzing it. all this stuff on this side is to just break up the domain. So if the domain is a straight line, all this is doing is busting up the domain and saying, okay, this part goes with the first function, this part goes with the second function, this part goes with the third function. I mean, we're not going to have functions that say, if, you know, square root of x squared minus 1 is less than or equal to, I mean, you're not going to have crazy stuff over here. All this structure is doing is busting up the domain. And when you realize that, then it takes all the mystery out of this. You're like, oh, okay, we're just gluing pieces together. Okay, I'm going to pause the video and put the answer down. Right, so time will have elapsed more quickly for you. So I just scrolled this in case you want to pause the video in order to give yourself a chance to try it. Okay, now I'm going to release the answer. Ready? Okay, that's the answer. Okay, so you should know how to graph parabolas. Okay, so but this is the parabola we just graphed up above, and if there were a vertex, it would be right down here, right here. But I didn't draw the vertex, but that would be where 1 is. Okay. What else? So I also, so the red axes are here, red axes, and then the -2 and the 2 are the green line. So x equals -2 and x equals 2. I guess that's all I have to say. Hopefully that's self-explanatory. Okay. Okay, I'm going to talk about the quadratic formula before I continue the other questions I want to do on this video, and I very well may do this again in person. Even though technically you only need to see the proof once when you first learn the quadratic formula, I think that a lot of people don't get it the first time, and it's something we use all the time, and I feel very uncomfortable asking you to use something that you don't understand. And so this is the quadratic formula that you know and love. And it can be used to find the roots of any parabola and to classify parabolas. But where does it come from? Okay, it comes from the idea that you're looking for zeros of ax squared plus bx plus c. All right, and then what do? Well, I'm going to divide off everything by a, and so the a is going to look like it disappears from the first term, but it's really going to still be there. Alright, so it's still there, but I divided everything by a. Now what I'm going to do is I'm going to put this piece on the other side. Why? Because it's kind of getting in the way. What I want to do is called completing the square, and I'm going to just show you graphically what's going on here. If I had, that would be a square if I wanted it to be a square. Let's see, it looks more like a square. There you go. Looks a little bit square-like. Okay, if I have something that's a square, I'm looking for it to have this shape. I'm looking for example, x squared to be here, and I don't know what the leftover piece is, but I'm going to take b over a. I'm going to slice it in half. Okay, so this is going to be bx over 2a, this is bx over 2a, and you may say, whoa, what's she doing? Well, if this length is x, this length is b over 2a, and I'm measuring out carpet, this length is x, it's a square piece of carpet, b over 2a. Okay, so then what's happening is this length of carpet is x by x, so I get x squared. And each of these little pieces, so I originally had bx over a, so if I had bx over a, whatever it is, bx over a, I take scissors and cut it down the middle, and then put half over here and half over here. That's all I'm doing. I'm just taking a rectangular piece and splitting it into 2 equal pieces because I'm trying to rig this so that I can fill in the missing square. Well, the missing square must be b over 2a squared because that would be the missing piece. So if you could visualize it, then it shouldn't seem so mysterious as to what we're doing. So what I want to do is I want to put b over 2a squared on both sides. Just make another copy of this. Okay, and then I'm going to just, well, you know, I'm just going to go ahead and do this. Plus b squared over 4a squared. I'm just going to go ahead and work that out instead of leaving it in parentheses. And that's why I'm doing that, because then in the next step, so I'm going to get common denominators, I guess 4 times a, 4 times a. Okay, now I'm going to put all these pieces together. B squared minus 4ac over 4a squared equals this quantity squared, which I've now successfully completed the square. But if what we're trying to do is solve for x, we want to take the square root. So we take the square root of the top of this fraction, we take the square root of the bottom of the fraction, we take square root of the right hand side. And we are almost done. We just need to put that b on the other side. You get a negative b. And sorry, it's a little bit messy. I'm trying to smooth it all onto the screen. Let me move these guys out of the way a little bit. I can shrink them. You don't need them anymore. Okay, so this is the quadratic formula that you know and love. Sorry, that's not a square. Anyway, right. So let me. Okay, so now let's say we want to find the x values either where f of x equals 0 or where two functions equal. So it's really the same question in disguise. The book listed as two different problem types, but I listed as one problem type because 0 is a function. They're really the same question, right? So in this case, if I let the first function be f and the second function be g, I'm just looking for where x squared plus 1 equals 3x minus x squared. So I'm just going to solve for x. That's it. It's just a quadratic formula. So I'm going to get 2x squared minus 3x plus 1 equals 0. This actually does factor, but I don't blame you if you look at that and say, I'm not going to bother seeing if it factors, because you know what? It's actually pretty easy, because if there's a 1 here or a 1 here, then it's pretty easy to test. But let's pretend like we didn't notice that. So let's go ahead and pull out the quadratic formula, because eventually, for some problems, you will do this. We may as well do it now. And then we just pop all our values in. So this is A, minus 3 is B, and 1 is C. So we're going to put all those values in. Negative B, B squared minus 4AC all over 2A. The most common place for mistakes is you see there's a negative right there. Humans don't like negative signs. Okay? And so especially make sure, look at A and see the signs of A and C. They're both positive, so the negative sign stays where it belongs. If there's just one negative sign, obviously it annihilates the negative sign in the formula. But the most common place to make errors is if A and C are both negatives, then you have 3 negatives stacked on top of each other, so it goes back to being negatives. And most students will make it positive. So just be aware. Just count your negative signs. That's all. This is very, very simple. 9 minus 8 is 1. So we get 3 plus 1 over 4, which is 1, or 3 minus 1, which is 2 over 4. So here are your roots. Okay, next question. Find x values for which this guy, f, equals this guy, g. Okay, so go ahead and do that. Let's see, we get 2x squared, because I'm going to add x squared to both sides. And I'm going to subtract 4x from both sides. Now, I can use the quadratic formula just like that, but that's not really wise. I may as well divide by 2, since I have a common factor. And then it looks a lot less intimidating, and then you should probably be trying to factor this, because it's really, really easy now. We have a plus on the 4 and a minus on the 3. X is equal to negative 4 or 3. And this is all I'm going to do for the snow day. The rest I'll see you later. Have a good snow day.